Good day everyone, I am Haider Sega from BSEE2B. So I will now discuss my first example. So find I/O in the circuit figure 10.19 using the concept of source transformation. So the goal of source transformation is to make the given circuit simpler in order to determine the needed electrical quantity. So from here, as you can see in the figure, so there are reactances that are in series. So we could simplify them by just combining them. So this is now the simplified circuit of the above figure. And we could still further simplify it, and we could transform this current source into a voltage source using this formula. Vs is equal to Z sub S times I sub S. So substituting to the equation, in the value of Is or the current source is 72 angle of 90 degree multiplied by the impedance that is parallel to the current source, which is 24 minus J18 ohms. So which is equal to 1296 plus J1728 volts. So as you can see here now, we have here two reactances that are in series, so we could just combine them, and the resulting impedance would be 36 minus J12 ohms. Now then, we could still simplify it, and we just have to transform this voltage source back in the current source. So in order to transform this voltage source, we just have to use this formula. So Is is equal to Vs divided by Zs. The value of Vs is this 1296 plus J1728 volts divided by the impedance of this 36 minus J12 ohms is equal to 18 plus J54 amperes. So in this figure, we could see this this J30 is parallel to 36 minus J12. So finding their reactances, it is equal to 20 plus J20 ohms. So now these two could already be considered as a two single reactances. So we could just transform this current source back into the voltage source. So the current or the circuit will now look like this one. So we have here the 20 plus J20 ohms in series with 6 minus J12 ohms. And then, so seeing this figure, so from this figure we could now find the value of I/O using the Ohm's law. So in order to find I/O, so I/O is equal to the V, which is the value of the source, which is equal to negative 720 plus J1440 divided by the R, or the resistance. Since these two are in series, so we just have to add them here at the denominator. So the value of IO therefore now is equal to 50.91169 angle of 81.8699 degree amps.